Welcome to you, everyone. In this session, we are going to learn about. Previously, we learned the manufacturing and molding. Different types of moldings are there, and injection molding we have learned. Now we are going to learn the blow molding. This is the blow molding picture. You can see that extrusion blow molding. This is called. In this one, we can say we can say we can divide into three sessions. That is partial extrusion, blow molding, and part formed. In this three, we can see that exactly here there is two in blow molding. There is two mold halves. Okay, you can observe here one we our product is here. We are for example, I have taken a water bottle. In this water bottle is our product. For the water bottle product, I have seen water bottle mold halves. That is two mold halves is there for that one. uh, Two mold halves is there. In between we have air house and a die head, molten plastic, blow pin, and extruder. Extruder will be pass as the molten plastic into the blow pin. Blow pin will be blow pin will be eject the molten plastic into the die cavities. That is mold halves. Okay, in the session you can in this second figure you can see that mold part, the two mold part will be jointed together with extruded and the mold. In this one molded part, we have with the help of extruded, we have injected the molten plastic. Okay, molten plastic into the mold halves. So that liquid will be forms a water bottle. Okay, see in the third figure we can see the final product. That means with the help this is called a blow molding. With the help of a plastic mold and the extruder, we are passing through an pin, we are passing through a blow pin into the mold parts. Here we have two mold parts. Okay, half that mold parts will be depends on the your product. I have taken a water bottle, so my two half of mold parts will be water bottle shapes. Okay, see, the blow molding is a tube is extruded first, then clamped into a mold with a cavity much larger than the tube diameter we have seen in the figure. Finally, it will be blown the outward it will be fills the mold cavity. So we can get the uh, product. That means I have taken the water bottle. We can get this will be happened at a pressure from 350 kilopascal to 700 kilopascals. Okay, with the pressure only that molten plastic liquid or any material will be extruded, will be passes with the some pressure. So in blow molding, the pressure will be maximum 350 to 700 kilopascals. Okay, now we'll see the rotational molding. This is another type of molding. In this rotational molding, we can take two molds. That is a round shape molds. In previously we have taken previously we have taken two half of molds per water bottle. Okay, in that one with the help of pin extruder, we have injected the plastic molten into that molten halves. Okay, we can get the final product as water bottle with the help of 350 to 700 kilopascals. We have done that. Here in the rotational molding, one of the differences, we have taken round shape molds. In the first mold, we have taken polymer powder. It will be we have taken the polymer powder, and then we have closed it with the another half of the mold, and we have axis, rotational axis, top and bottom. You can see that here. Okay, here and the bottom, it is with the help of this we are going to rotate this moldings, two moldings. This polymer powder will be comes from the polymerization, and we are going to heat that. Polymer port with the help of polymerization. We can get the uh, final product. That is, after heating we are rotating it. You can see that rotation shapes here in the figure. With the help of this, we are going to rotate and heat it. After the heating, we are going to slowly cool down, not suddenly. Slowly we are going to cool down, and we are continuously rotating it. In heating and cooling both, we are continuously rotating in that one. We in between that, we are having polymerization powder. It will comes from the polymerization powder. After that, we get the demolding. In the demolding, we are get our final product. It is a round shape one. That is, in this one mainly we have done the product with the help of rotating. Okay. Heating, cooling both are done by the rotation. We can see the rotation symbols here and here in the figure, and in cooling also we have done that. So with the help of rotation and heating, cooling, we have done the product, final product, that is comes under final product. So we are call it as rotational molding, because of with the help of rotating we are doing. So this is rotational molding. Rotational moldings, you can see that thermoplastic and some thermosets can be formed into large hollow parts by rotational molding. Mostly with the help of rotational molding, it knows that thermoplastics and thermosets will be molded with this rotational molding. And the thin walled metal mold is made up of two pieces. We already discussed thin metal mold is made up of two pieces, round shaped two pieces. One of the one of the piece has one of the mold having we have pouring the polymer powder. One will be closed and heating, cooling, again heating, cooling within a rotational axis. Okay, perpendicular axis, that is, and is designed to be rotated about two perpendicular axis. We can see this here in this figure, bottom and here side. Okay, that is, we have designed about two perpendicular axis. Okay, two perpendicular axis, it is going to rotate. So the pre-measured quality of powder plastic materials placed inside the warm mold. We know that after that we are going to close, after that we are going to heat, and the perpendicular axis will be going to rotate. After that again cooling, and then final product will be there. Next, the powder is obtained from a polymerization process, that is precipitated a powder from a liquid. The mold is then heated, usually a large oven, while it is rotated about two axes. Again, it will be going to cool with two axes. So we made like its applications are, we are going to done using this molding tanks of various sizes, trash cans, boat hulls, buckets, toys, carrying cases, and footballs, volleyballs, different types of parts we are going to do using the rotational molding. Now coming to the compression molding, it is one type of molding with compressing. The product will get by compressing. See here in this figure, we can observe upper movable mold half. It is called. It is a lower fixed mold. One mold here also two molds will be there. In these two molds, we are one is movable mold half. One is movable mold half. One is lower fixed. Lower one is fixed mold half. One is fixed. One is movable. So lower one is fixed and upper one is movable. In that lower fixed mold half, we are going to put our charge. Charge means we are going to put our plastic, thermoplastic, thermoset, or liquid or solid, anything, whatever product we needed, whatever material we have selected, that material we have melted and we have keep on the lower fixed mold half. And then upper movable mold half, with the help of upper movable mold half, it is going to compress. Upper movable mold half, it is going to compress. You can see the second figure. In the second figure, it is going to compress. So after compressing, it is going to be like this. This is our final. This red shape one is, after removing this upper movable mold half, we are going to get this red shape product. It will be adjustable by the ejector pin. Okay, it will be there, ejector pin will be there. So we can do two mold halves. Is in compression molding, we have two mold halves. One is movable, one is fixed one. In the fixed one, we are going to keep our material. With the help of movable mold, we are going to compress that our product, we can get final product of final product which we needed. So we can see that a pre-measured volume of powder or viscous mixture of liquid resin and filler material is placed directly into a heated molded cavity. We have seen in the previous figure, we can see in this figure, we can see that first figure we have placed our cavity. After that, forming is done under pressure from a plug or from the upper half of the die, that is movable die. With the help of movable die, we are going to form. Compression molding results in the formation of flash, which is subsequently removed by trimming or by other means. Here we can get a product when we are doing the product. Here in the first figure, when we are compressing that, we can get some flash or some removable content will be there. Removable things will be there. Removable material will be there. So that will be removable by trimming. Okay, and there are three types of compression moldings are there. Again, there are three types of compression moldings are there. That is, one is flash type, positive type, semi positive type. Flash type, with the help of flash type, shallow or flat parts will be made. And positive type, with the positive compression molding we will do for high density parts. High density parts will be done through the positive compression molding. And quality production dies for compression molding are generally less costly than those used in injection molding. So semi-positive is doing for quality production, and dies for compression moldings are generally less cost compared to the injection molding. When you are compare, we have seen in the last session, injection molding. With the help of injection molding, we are going to plastic raw material will be converted into molten, and then we have done the product. Here also in the compression molding we are doing, but when comparing to that two molding process, injection molding process and compression molding process having less cost compared to the injection molding. So next, coming to the transfer molding. Transfer molding is also same as an compression molding, relatable to some compression molding. Here we have plunger and transfer pot, charge, sparse, mold cavity. This is our mold cavity. Previous to that compression molding, in the rubber transferring mold, we are keep some rubber or liquid something in the charge. We will keep in the fixed mold. One movable mold plunger will be there. The plunger will be pressures the charge. When pressuring the charge can be passes through the spurs. After it is passes through the spurs, after it will be reaches the mold cavity, and it will be occupy the mold cavity. That is our molded part. After some time you will remove that movable plunger. If you remove the plunger, we can get molded part. You can see that our molded part in the second figure. So rubber transfer molding, this is the rubber transfer molding. That means we are transferring the we are in the first figure, you can understand, from the first figure you can understand, that is charge. When it is compressed, it will be compressed or heated. When it is heated or compressed, it will be going to change its position, and it will be fulfill the mold part. Okay, the uncured thermosetting material is placed in a heated transfer pot or chamber. We know that we are placing here in the figure. You have observed that after the material is heated or injected into heated closed molds. That means we are going to heat or inject, or we are compressing that. When you are heating it, it is slowly transfer. In the figure you can observe, slowly transfer to the mold cavity. It will be occupies the mold cavity through the spurs. So a ram or plunger or rotating screw feeder forces the material. That means we are forcing the material to flow through the narrow channel into the mold cavity. After it will be reaching the mold cavity, when you removing it, we are getting the mold part. This is the eighth one. You can see that mold part. This is the final product we are getting. So using this transfer molding, we are going to get electrical and electronic components and rubber and silicon parts. It's using the rubber molding, we are going to get rubber and silicon parts mostly, and electrical and electronic components like wires, electronic components, different types of components we are going to transfer in this type of molding. Next session, we'll start in molding. Different types of molding has completed. Now we are going to see different types of casting methods. Thank you everyone.